Hello, good day. Welcome again to my channel. This is Engineer Ernesto C. Prudenciado Jr. And let's continue discussing to our course, Engineering Mechanics. So, we already finished discussing the two related topics with regards to cables. So, that is parabolic cables and catenary cables. So, this time around, we will discuss cables under concentrated loads. To better understand this, so let's go straight to the example problem number 10. Okay? Determine the tension in each segment of the cable shown. Okay? So this is the cable given. So this one is the cable AB or the segment AB. This one is the segment BC. And this one is the cable CD. First, we have to inspect that which segment, because according to the problem, we will ask to solve for the tension of all segments. Okay, so we will analyze first if what segment can be possibly solved. So by inspection, we can have CD because there is a given angle 35 degrees. Okay. So the problem won't tell you if which segment to solve first, but it's your job to determine which of this segment can be possibly solved. Okay, so it is impossible also for the examiner to have a figure without this angle because that is impossible to solve. So because 35 here is given in this segment CD, so this is a hint already that CD would be solved first. Okay? Let's solve. From the figure, so summation of moments about A equals to 0. So let's sum up. So there is a component here. Let's say DH. This one is D vertical. Okay, so summation of moments about A, DH, because DH is counterclockwise, so take counterclockwise as positive. Okay, so let's continue. DH times 6, the moment arm, plus DV times how much? 7 plus 11, 18, plus 6, 24. Okay? Minus 16 times 6 minus 20 times 6 plus 11, 17, equals to 0. So, DH times 6 plus DV times 24 minus, let's solve this, 16 times 6 times 6 minus 20 times 17. Okay, so negative 436 equals to 0. Okay, so we can express DH in terms of DV. Okay, let's solve. So DH equals 436 minus DV times 24 over 6. Okay, so DH is equals to 436 divided by 6. So this is 72.67. Okay, minus dV times 4 or 4 dV. Okay, so this is our equation 1. Okay, so let's draw a triangle. this is dv, and this is dh. Okay, so we have here theta, and we know that this is 35 degrees. So tangent of theta, the tangent of 35 degrees equals to dv over dh. So we can have another equation in terms of dh, or yeah. So dh is equals to dv over tangent of 35 degrees. So what is dh? So 1 divided by tangent 35. So that is 1.4281 dv. Okay, so this is our equation 2. Okay, so we can now solve dv by equating equation 1 and equation 2. So what is that? 72.67 minus 4 dv equals to 1.4281 dv. Okay, so what is dv? (72.67) minus 4 alpha x equals 1.4281 alpha x. Cheap soap. So dv is equals to 13.39. Okay, this is in kilonewton. Okay, since we have dv already, 13.39, so looking at this triangle, this is CD, we can say that sine of theta is equals to the opposite, which is dv over the tension of the segment CD. So substituting sine of 35 degrees equals to dv 13.39 over tcd. So we now have tcd equals to, so this is the answer divided by sine 35. So the answer is 23.34 kilonewton. So we now have the tension at segment CD. Okay, so this is our answer for the first question. Okay, to solve for the segment BC, so we can draw a force polygon at point C, this one, point C. Let's analyze that. So let's draw a force polygon. This is 20. Okay, so this is TCD, this is 20, and this is TCD, which is 23.34. So this is what? 35 degrees. Therefore, this is 55 degrees. 90 minus 35. Okay, so we can now solve the line TBC or the segment TBC. Okay, by using cosine law. Okay, so cosine law is equals to TBC squared equals 20 squared plus 23.34 squared minus 2 times 20 times 23.34 cosine of 55. So what is TBC? Okay, solve this. Alpha x squared equals alpha x squared equals 20 squared plus 23.34 squared minus 2 times 20 times 23.34 times cosine of 55 shift solve. So TBC is 20.23 kilonewton. Okay, so we now have the answer for the second question. So, okay. So, this one is the problem. Okay, so to find the tension at AB, we have to solve first the beta 2, this one. Okay, so we can solve the beta 2 from this triangle. Okay, we must first solve the angle here, which is the beta 1. Okay, but first we have to solve this. Okay, what is this theta? Okay, so we can have sine law for this. Okay, sine of theta over 23.34 equals to sine of 55 over TBC. But TBC is 20.23. So theta equals shift sign. So this is 70.92 degrees. So but be careful in using this sine law, no? Because sometimes the calculator will give you the complementary angle. So it's very safe to use always cosine law. Okay, so let's check using cosine law if the angle is correct. So for cosine law, okay, so we can have this one, the opposite. So 23.34 squared equals the two sides, 20 squared plus TBC is 20.23 squared minus 2 times 20 times 20.23 cosine of theta. So we can solve theta. (23.34) squared equals 20 squared plus 23. 20.23 squared minus 2 times 20 times 20.23 cosine of alpha x. Shift solve. So the theta is 70.92. So the same, no? So that's good. So therefore theta is 70.92. We can solve for beta 1. Beta 1 is equals to 90 minus 70.92, which is equals to minus 90. Okay, so 19.08 degrees. Okay, let's copy the figure. Okay, so we have already beta 2. We have already beta 2. We have here. Now, we have already the tension BC. So we can solve for the tension AB, okay, by method of joint. So we have to draw the free body diagram of that. This is TBC. This is TAB. Okay. TAB. Okay. So we now have this angle. This is 19.08. So let's call this as alpha. Okay. So summation of forces vertical equals to 0. So TAB, okay, this is going up. TAB sine of alpha, okay, minus, by the way, this is 16, okay, minus 16, okay, minus TBC, which is, we know that TBC is equals to how much? 20.23. 20.23 times sine of 19.08. Okay, we now have equals to 0. Okay, so TAB sine of alpha equals to 20.23 times sine of 19.08 plus 16. So this is 22.61. So this is equation 3. Okay, so summation of forces horizontal equals to 0. So TAB cosine of alpha equals TBC cosine of 19.08. Okay, so we all know TBC is equals to 20.23 cosine of 19.08. So TAB cosine of alpha equals cosine of 19.08. Okay, so this is 19.12. Okay, so this is our equation 4. Okay, so divide 3 over 4. So this becomes TAB sine of alpha equals 22.61 over TAB cosine of alpha equals 19.12. So this will cancels out. This becomes tangent of alpha. So sine over cosine is tangent of alpha. Remember in your trigonometry, over or equals to 22.61 divided by 19.12. So how much is that? So 1.183. 183. Okay. So to solve for alpha, so alpha equals 49.78 degrees. Okay, So if we have this alpha, we can now solve TAB. Okay? Take equation 3. Okay? So what is equation 3? TAB times sine of alpha equals 22.61. So TAB sine of 49.78 degrees equals to 22.61. So TAB is equals to 22.61 divided by sine of 49.78. So the answer is 29.61. Okay, so this is the answer for the last question. Okay, so thank you for listening and hope you learned from me. So bye-bye. Take care. God bless.